Hello, my name is Viktoras Giannikopoulos, and I'm here to present you my project with the title Interstellar Probe and the Rise of Quantum Artificial Intelligence in Deep Space Quantum Technologies and AI for Communication and Autonomy Beyond the Heliosphere. So, here we see the structure. We start with bit to qubit, how Voyager communicates with Earth using the bit technology, anion qubits, and Neura in quantum computing, and cooling and sealing of anion qubits in Interstellar Probe mission. And before I start, I want to say an important note. Anion qubits are currently at the level of research and experimental simulations. So far, no practical implementation in fictional quantum computers has been achieved. This presentation here should be as a future perspectives with a possible timeline for 2030. The goal is to highlight the potential role of this technology in the future space missions. So, here at the first slide we see a century of quantum physics. We start with Planck, Einstein, Bohr, Heisenberg and Schrödinger. We continue with Schrödinger's cat, followed by experimental kits with Feynman, Bell and Aspect. From the 80s we see technologies such as laser, cryptography and medical imaging. Today we're in the second quantum revolution with quantum computers, AI and pharmaceuticals. And the future brings also big questions. Quantum gravity, unification and the quantum internet. From bit to qubit, so let's have a comparison between them. Bit has only two states, 0 or 1, and works with logical gate, always producing a fixed result. But, on the other hand, qubits are in superposition, both 0 and 1, at the same time, described mathematically as a combination of the two states. How Voyager communicates with Earth. Both Voyager 1 and 2 launched in 1977, and they still communicate with Earth using bits with the Deep Space Network in the USA, Spain and Australia. They rely on a high-gain antenna, an X-band and S-band, but of about 22 hours on a way of 44 hours round trip. Recently, key restorations were made. Thrusters were reactivated and Voyager 2 was recovered through a so-called shoot, a signal from Earth. So, I have prepared you two videos for today. Let's start the first one. There is a limit, an invisible boundary you cannot see, but you know it's there. It's the point where the power of the sun causes to ring, where its protective shield ends, and the vast, frozen, dark interstellar space begins. It's the end of our neighborhood in the universe, the beginning of the unknown. Until the day, no mission was originally designed to cross that boundary. Until today, the Voyager 1 and Voyager 2 mission, which decades ago were designed to reach the helios, and yet, with computers less powerful than a simple mobile phone, with technology that today seems almost primitive, the Voyager traveled, crossed the limits, and found themselves in interstellar space, an achievement of endurance and persistence. Without advanced systems, without sophisticated technological machinery. But now, this changes. For the first time, we are designing a spacecraft for its very first crew, with the sole purpose to leave the solar system and keep going. The Interstellar Probe is a dream becoming a plan. The mission that will go farther than any other human creations. Over 1,000 astronomical units, more than 150 billion kilometers from Earth. Launch between 2036 and 2040, 50 years and beyond, with no return. As it shared, it will not beat the technology of the past. No, it will beat with a pioneering system based on anion qubits, a type of topological quantum information so stable and resilient that it can operate in the harshest environment of the universe. These qubits will work alongside quantum artificial intelligence, not an AI as we know it today, but an entity that learns, adapts, and makes decisions on its own. A captain capable of traveling alone, without distractions from Earth, without signal, without help, for decades. NASA, in collaboration with MIT, Microsoft, the GPL and the APL, are suddenly working on this technology. A technology that aims not only to take us farther, but to expand our boundaries. The interstellar probe is not just a mission. It is humanity's next step. Proof that can create something about by time, space, all the limits we once thought insurmountable. This is interstellar probe, the first spacecraft designed to live and keep going. So, let's continue. What are anion qubits? Here we introduce anion qubits, marking a new era in quantum computing. Anions are special quantum particles that exist only in certain two-dimensional materials. Their information is stored not in local states, but in topological braids. This topological nature makes them highly resistant to error and noise, which is essential for building stable quantum information. So I'm going to give you an example. Wait a second. So you see here this rope? If I have it straight and I pull it, we see that it's changed easily. This is like classical qubits. The information can leave easily. They are sensitive to noise. But if I tie a knot right here, we see that if I shake it or pull it or anything, the information is here. The knot is not removing. That's why, because they are topologically protected. So, even in extremely condition, anion can have data without loss. This is not a billion anions. So, synergy between anion qubits and quantum AI. These slides show the synergy between AI and quantum qubits and anion qubits. Anions provide stable and fault-tolerant qubits, which quantum AI leverage for error corrections, simulations, and new algorithms. Applications range from physics and chemistry to deep space, where the robustness of anions supports reliable communication and real-time decision-making. So, how do anion qubits work? Classical particles are either boson or fermions, depending on how they behave when exchanged, but only in two-dimensional systems. A third type appears, anions. When they are breathing, as I gave the example before, the quantum state of the entire system changes. But this change depends on the path, not just the end of the point. But why this matter for qubits? In anion qubits, information is not stored locally, like an electronic spins or range, but in the topology, in the breathing of multiple anions. This bridge acts like quantum logic gates, meaning computation are performed simply by moving the anions around each other. But anion qubits have some recruits. First of all, we need ultra-low temperature cooling. Anions need around 10 to 20 millikelvin, close to absolute zero. Space itself provides a natural cooling background at 2.7 Kelvin, while advanced cryogenic and microcooling systems maintain this state reliable for long duration missions. Secondly, electromagnetic shielding. Beyond cooling, anions also require strong shielding from electromagnetic interference. Multi-layer materials like copper and aluminum block radiation, while superconducting magnetic shielding creates ultra-low noise zones, protecting qubits from space weather and internal disturbances. Okay, so you see here this picture? These slides show how we cool and supercondition quantum circuit using liquid 3. So let's start from the left. As you can see there, we see the difference. Without helium-3, the circuit suffers for environmental noise, but when immersed in the liquid, thermal coupling improves and energy losses are reduced. Now, let's look at the center. The circuit is placed inside the cooling chamber, where helium-3 lowers the temperature to ultra-low level, as we can see there in the blue, down to 0.4 millikelvin, which is extremely close to absolute zero. And last, let's look at the right. We see how heat is removed and how the cooling keeps the system stable. Simply put, we immerse the circuit in an ultra-cold bath, so it can operate noise without maximum stability. Vibration isolation. Mechanical vibrations can destabilize quantum coherence. Qubit modules are mounted on vibration-isolated platforms to reduce effects from thrusters or structural shifts. Decoupling and damping technologies prevent structural or acoustic disturbances from reaching the quantum subsystem. And last but not least, we have environmental control. Environmental control is so important and so essential for the stability of anion qubits. Conditions like vacuum pressure and humidity are tightly regulated, while interstellar space provides an almost perfect vacuum free of noise. This reduces error and enhances qubit survival during long missions. Let's have a conclusion. The foundation backers of Planck and Einstein the development of anion qubits and quantum AI, where we notice the transition of qubits from theory to applied technology. Topological qubits ensure stability, and fault tolerance enable large-scale computation with minimal errors. Quantum AI brings autonomy, optimization, and real-time data processing, with application ranging from complex systems simulating to interstellar space. The synergy of these technologies is not a scientific leap, but also a vital step toward ensuring humanity's survival and persistence in space. Ultimately, every scientific advance is guided by the same principle: serving humanity's and securing the future of our species. So, anion qubits, topological quantum bits, extremely stable and resilient, capable of operating under extreme space conditions for decades. Quantum AI learns, adapts, and makes decisions on its own, acts as the captain of the spacecraft without direct instructions from Earth. Real-time communication. In the Parker Solar Probe mission, Earth temporarily loses contact with the spacecraft when it passes within 6,000 kilometers of the Sun. And now, this is my message for you. Once, Albert Einstein was asked how he imagined the Third World War, and he replied, "I do not know how the third will be fought, but I know that the fourth will be fought with sticks and stones." Today, however, we can say something much clearer. We know how the third will be unfolded. It will be a war unlike any other in history. A war both nuclear and cyber. Weapons of the physical kind and weapons of the digital kind. Unleashed from every molar stern, without limits, without breaks. And the fourth, it will not happen. Not because we will return to the edge of caves, but because the human species will no longer exist. Artificial intelligence will not wait. It will not need for humanity to end to take its place. It will have already ended the human era, much sooner than we can imagine. Life, however, always follows cycles. All forms of life are born, evolve, and fade away. Some last millions of years. Humanity's existence, as things are going, will have a tragical short cycle, but there is a hope. If we choose, we can set rules now, not tomorrow, not when artificial intelligence defines a framework on its own, but us, humans, before it's too late. Otherwise, the end will be quiet, cold, and absolute, and perhaps in the absolute silence, a new species may emerge, a species that will no longer need us, a species that will continue where we have stopped. The time for action is now, before technology decides for us. Thank you very much.